the transformation stuff because I've been talking to a couple people, and they've been having a hard time figuring out what to do when, like what's horizontal, what's vertical, all that kind of stuff. So I'm just going to use the greatest integer function as an example, but this is for any function. So whether these are absolute value bars or anything that we discussed today. If it's happening inside the function, it's horizontal, and if it's happening outside the function, it's vertical. That means anything that's happening in here to x is some sort of horizontal change. Okay? And anything that's happening outside of that, so like stuff that's multiplying up here in front, or stuff being added and subtracted on here to the back, those changes would be vertical. So when you guys are listing the transformations, like, oh, I don't know if this is a horizontal stretch or a vertical compression or something like that, this is what you should be thinking, at least for horizontal and vertical. Okay? Then you should remember, and you guys have all this stuff on the back of your blue organizer. This is just like another way of saying it to try and help you, those of you that are struggling, that there's basically 3 types of transformations. Okay? There are either translations. What are the other ones? Reflection. Or we can do some like stretching, compressing action, right? Okay. When is something a translation? What kind of operation, if you see this operation happening in an equation, it should shout out to you like, oh, there's a translation going on in this problem. What math operation, when you see it, you say, oh, it goes left, it goes right, it goes up, it goes down. Plus or minus. Stuff being added or subtracted, right? So this is going to anytime you see something being added or subtracted, you should be thinking, okay, this is in the world of translations, okay? Shifting left, right, and up, down. If it's being added and subtracted outside the brackets, like right here, it's going to be an up-down type of translation because that's vertical. Whereas when it's something being added or subtracted inside of the brackets to x, it's going to be left-right translation because it's horizontal. Okay? Reflections. What do you see in an equation that's a big red flag to you that one of the transformations going on from the parent function to there is a reflection of some sort? Negatives. And the negatives aren't being subtraction type of idea. The negative is being multiplied by something, right? So anytime you are multiplying by a negative, then you should think reflection. Again, when is it what type of reflection? If the negative value is out here, okay, then it's going to be a vertical reflection because that's happening outside of the brackets. If it's inside here multiplying x, then it's going to be a horizontal reflection. Okay? And then lastly, the stretches and compressions are anytime we are multiplying by some number that is not 1. So anytime there is another number out in front over here or out in front of x in the brackets, that's some sort of stretch and compression. Okay? So does this help a little bit kind of summarize and clarify now that you've seen that? Now, the other thing to make a note about is that horizontal and vertical stuff work differently. Okay? Reflection is kind of the same. They're each being flipped over an axis, and you know which one if you've decided if it's horizontal or vertical. Okay? But translating is not the same. If I write +1 after the function is done, okay, outside the brackets, that's a vertical shift. And does it go up 1 or down 1? Bless you. Does it go up 1 or down 1? +1 outside the brackets. Up 1, just like you see it, up 1. But what if inside the brackets it said x + 1? Okay, good. It's inside the brackets, so it's horizontal, and it's to the left one, not to the right one. So the horizontal stuff's like wacky, right? You see +1 out here, it means exactly what you would think, up 1. But you see +1 in here, it doesn't mean what you would think at all. It actually means left 1, okay? Same thing with when you multiply stuff inside the brackets. If I multiplied by a 2 outside the brackets, okay, it's vertical. I'm multiplying by a number, so it's either a stretch or a compression. In vertical land, okay, outside the brackets, when you multiply by a 2, are you stretching or compressing your graph vertically? Stretching. It's exactly what you would think. Just like the +1 means move up 1, the 2 means 2 times bigger than what it used to be, stretched out. Okay? But if I put a 2 inside the brackets multiplying x, okay, in horizontal world, okay, is that 2 a stretch or a compression? It's actually a compression, okay? Everything inside the brackets is kind of like the opposite of our intuition. Like you see +1, it's not moving on the right one, it's moving to the left. You see ×2, it's not stretching it out ×2 horizontally, it's actually compressing it, okay? So now you know where the horizontal stuff is, where the vertical stuff is. You know which one's going to go with the word translation, reflection, and stretch or compression. And then you're going to have to work a little harder to tell apart the horizontal stretch and compression versus the vertical stretch and compression. Does that make sense to everybody? Yeah. Yeah, so on your test, I'm going to ask you for the transformations. And when you list the transformations, when you list like reflection, you can just state with it that it's horizontal or vertical, or you could say which axis it's going over. If you're listing translations, you don't have to say horizontal or vertical because I need you to be even more specific, like up 1 or to the left 1. Yeah. And then for stretches and compressions, you do need to say whether it's horizontal or vertical and then stretch or compression. So for both of these, you should say the words horizontal or vertical. With this one, you don't necessarily need to say the words because you're going to tell me specifically which way on the graph and how many units I should be translating, okay, or shifting. Does that make sense to everybody? Any kind of expectation there? All right, then looking at your blue organizer that you have, we have how many doors filled in? Just one, right? The absolute value door? Okay, so you have 8 doors in total. Every door is going to be set up the same. So you saw in the absolute value function one, you have the name of the function, the graph of the parent, and then you have the parent equation written right below it. Okay? You're going to do the same thing, but on this door, we're going to do greatest integer function. So right now, you can just write in all the titles, and then we'll go through each one. We're only going to do the outside of the door today, so we're just getting what does the parent function equation look like, and what does the parent function graph look like. Okay? Below that, we're going to do a square root function. And below that, we're going to do a cube root function. We're going to also do 2 doors on the other side below your absolute value. We're going to do quadratic next to the square root function. They are related to each other. And again, you remember that the setup's going to be just like before. So just write the name across the top, leave room for the parent graph and the equation. And then we're also going to do a cubic function. So on the greatest integer function door, you have the title. At the bottom of that door, we want to write the parent function. And then in between the title and the parent function, we are going to create a graph of what the parent function looks like. So remember that our greatest integer function, the parent function, is all the stretches, reflections, and translations removed. So you just basically have x with this thing being applied to it. And remember to separate the greatest integer function brackets from absolute value, that those mean 2 different things. Okay? Like when we look at your homework later today, the first 3 graphs should have been V-shaped, and the second 3 graphs should have been steps. Okay? Some people did that, but then some people did steps for all of them. They kind of ignored when it was absolute value and when it was greatest integer function. All right, what's the basic shape of our greatest integer function? So when you see these brackets, what do you expect your graph to look like? Steps, okay? And then you have to know kind of where do we start our steps, and then how long are they, and how far apart are they. So we start at 0, 0. And how long are our steps? 1 unit long for the parent function. And then they're 1 unit apart. And they keep going in that manner. So you just want to know that parent shape so that then you can apply those transformations like we've been doing. and then you can finish getting the graph. So we've done this one a lot, so there shouldn't really be any questions about the parent function because you've seen this over and over again each time we tried to graph one of those. Okay? All right. Then we're going to do the quadratic function and the square root function, and we have them together. Okay? So does anybody remember what a quadratic function is, either by equation or by graph? So do you remember what it looks like, or do you remember what the equation is that describes what mathematicians call a quadratic function? No ideas? Okay, so I'll remind you guys it looks like this. Okay, yeah, so they call that a parabola. What does the equation have to have in order to make it a parabola? Good, it has x squared. So the parent function for a quadratic is just simply having the x being squared. Nothing being added or subtracted, nothing being multiplied in front, just the x being squared. Yeah, it's in the one below the absolute value function. All right, so if we graph this, just to get an idea of what the parent function looks like, you guys already know that it's kind of U-shaped or shaped like a parabola. What happens when you plug 0 in for x? What do you get for your y value? 0, so we have 0, 0. What about when you plug 1 in for x? 1. Do you guys agree with Scott? Okay. When you plug in -1 and square it, what do you get? So -1 times -1 gives us still +1. So it's starting to look a little bit like our absolute value parent function. Is it going to keep looking like our absolute value parent function if I plug in something else? Let's try. If we plug in 2, okay, meaning 2 goes in for x, what would you calculate as the y value that goes with that? 4. So now all of a sudden it's not like absolute value. It's not going the same steepness the whole time. It's like jumping and curving upward. That's why it makes a U instead of a V. So we plug in 2, and we get 4. And the same thing would happen when we plugged in -2, we'd get 4. So this is our parent function. And just for understanding, what would you get when you plugged in 3? 9. So it's just shooting up like higher, and every time you get further away from the 0, it's just shooting up higher and higher, which is making it more curved and almost look like it's going straight up the edges. Then just to the right of that, okay, we are going to do the square root function. Any idea why I would put the square root function right next to the quadratic function? Good. So you guys say the opposite. Have a little more specific terminology we'll get into later. Okay. And so the square root function is going to have a square root. Good. Y equals, and then just x in the radical. So all the parent functions are just like you have that special thing, squaring, square rooting, greatest integer, absolute value, just happening to x and nothing else being involved. And we actually did graph this on the back of your organizer previously. What kind of numbers, if I want to use real numbers, what can I not plug in for x? What am I not going to be able to calculate the square root of? So what's the square root of 0? 0. I can do that. Good, negatives. If I plug in negatives, I would get imaginary type of answers. And this is a real number axis, so those imaginary types of answers aren't going to correlate on this graph. So I'm not going to plug in any negative x values. Okay? So my graph's just not going to go over there because I don't have a real number answer for them. Okay? When I plug in 1, it'd be a good number to plug in. I take the square root of it, and I get 1. Now, I can plug in 2, and there is a square root of 2 that's about 1.4 or something like this. But let's go with 4. Yeah, it's a lot easier to plug in. When I plug in 4, I get 2. And we talked about last time how this graph is growing. It is getting higher and higher, but it's growing so incredibly slow. Like just to get up to a height of 10, I would have to go all the way out to 100 and plug in 100 before I would get up to 10. So it's not flat, but sometimes it appears to turn out that way because it's just growing so slowly. Okay? Any questions about the quadratic or the square root function? All right, so the last two doors that we're going to fill in are going to be the cubic. function. And then next to it is going to be the cube root function. Yeah. It's kind of ugly. All right. So, cubic function. What do you think a cubic function has in it? A cube, okay? And cubing means taking something to the power of 3. So our parent function here for the cubic is x being raised to the power of 3. All right, so we plug in 0, just like we did with squared, and we get 0. When we plug in 1, what will we get? What's 1 to the third power? 1. And what about when you plug in negative 1? Negative 1 times negative 1 times negative 1 actually makes a negative 1. So this is different from the quadratic in the fact that when we plug in negatives, we get negative results, and when we plug in positives, we get positive results. Now, right now, it looks like a straight line, okay? But again, think what's going to happen when you plug in 2. What happens when you plug in 2 for x? You get 8. So it shoots way up off your graph. And when you plug in negative 2, you're going to get negative 8 shooting way down. So what happens is it's not a straight line. It's actually curving and changing direction in between these. So it's coming up, it's changing direction through there, and then climbing up there. And it's not vertical, but it looks that way because, gosh, when you plug in 3, it's going to shoot all the way up to 27. So it's growing so fast that it looks vertical, but it's not. Kind of like how our square root function was growing so slow that it almost looks horizontal. Mm-hmm. All right, so why do you think I put the cube root right next to the cubic? Good. So the parent function is going to relate to the cubic like it is to the quadratic. So we had x squared and then the square root of x. Here we have x cubed, and now we're going to look at the cube root of x. Okay. And again, if I'm going to make a little sketch of what this is by hand and I have to plug in some numbers, I'm going to be really choosy about the numbers I plug in. Not that the other numbers can't be calculated, but I just don't know their cube root off the top of my head. Okay? But like 0, what's the cube root of 0? 0. All right, what's the cube root of 1? 1. Because when I ask what's the cube root of 1, I'm asking what number to the third power would give me 1 as an answer. And it would be 1 to the third power that would give me 1, says there. What's the cube root of negative 1? So what number to the third power would give an answer of negative 1? Negative 1. Okay, so every time I'm asking this, what number to the third power is going to give me this number that I'm plugging in? Okay, so negative 1 gave me negative 1. Again, it's starting to look like a line, but it's not. Now, do I want to plug in 2? Is there going to be a nice number to the third power that gives me 2? No. What number is a number that results from being something to the third power? 8 would be the next cube. So 0 is a perfect cube, 1's a perfect cube, and the next perfect cube doesn't come until you hit 8. Okay? And the cube root of 8 is 2. So until I go all the way out to 8, then I'll finally hit 2. So this is even worse than the square root function as far as how fast it's growing, right? It's growing really slow. And then all the way out to negative 8 is where you would hit negative 2. So what's happening with this graph is it's growing really slow too, so it starts to almost look horizontal also, but it goes in both directions because the cubing and the cube roots can handle negatives, but the square root can't. So that's what's happening with that parent function. Okay? So by the time we get to the end of this unit, you're going to want to know these 6 shapes, so that if I give you some crazy function that looks like, right? You would be able to graph this, okay? Because you would start with this shape, and then all you would do are all the transformations we would have done before. Like this -1 inside of here really means shift, not up 1, it's inside the radical to the right 1. This 2 right here, horizontal compression or horizontal stretch? Compression. Horizontal is kind of opposite of what we think. This 2 out here, a vertical stretch, a vertical reflection, and then a vertical shift. All of that stuff is going to stay the same. What's going to change is that it's inside a cube root, so it's this shape instead of the other shapes that we've studied. So that's kind of like our end result that we're headed towards. Okay? All right.